I'm Mr. Joseph, your chemistry teacher, still on ionic equilibria. These are the lesson objectives for us. So we're looking at, Ka and pKa, and also what calculate the hydrogen ion concentration and the power of the hydrogen ion concentration. So students should be able to define the terms Ka, which is the acid dissociation constant, and the pKa, and represent it mathematically, and also use them in calculations, and also calculate the hydrogen ion concentration and the pH values for weak acid. So please, I want us to listen attentively and get the best from today's lecture. So still on Ka and pKa, we are still looking at ionic equilibria. So Ka represents the acid dissociation constant, while pKa represents the negative logarithm to base 10 of the acid dissociation constant. From our previous lectures, we are made to understand that weak acid partially dissociate into ions in aqueous solution. A weak acid is an acid that dissociates what? Partially. For example, ethanoic acid is a weak acid. It dissociates to give you what? This ethanoic acid, which is a weak acid, dissociate to give you ethanoic ion and hydrogen ion. Now the equilibrium expression for this reaction, equilibrium constant Kc is equal to what? The concentration of the product divided by the concentration of the reactant. So the concentration of the hydrogen ion multiplied by the concentration of the ethanoic ion divided by the concentration of what? Of the acid. So the Ka is called the acid dissociation constant at 298 Kelvin. So the value for the acid dissociation constant for ethanoic acid is 1.74 times 10 raised to power minus 5 mole per dm cube. So that equilibrium constant is what to call what? The acid dissociation constant for what? For a weak acid. And we'll have so many weak acids. We'll have ethanoic acid, propanoic acid, butanoic acid. So we can write, the general formula for a monobasic acid as what? Ha, because most weak acids are monobasic. That means the basicity is 1. Talk about basicity is the number of replaceable hydrogen ion in an acid. So the balance equation for the partial ionization of the weak acid, we can use what? The Ha instead of using the ethanoic ion and the hydrogen what? Hydrogen ion. So the Ha generally represents all monobasic acid. So it's as simple as what? A, B, C. So still on Ka and pKa. So we can write the general formula for a monobasic acid as Ha. Have thousands of monobasic acid, ethanoic acid, propanoic acid, butanoic acid. So we use the general formula for a monobasic organic acid. So the balance equation for the partial ionization of this weak acid, you can see when it dissociates in water, it dissociates partially to give you what? Alkanoic ion and what? Hydroxonium what? Ion. So to make calculation easier, the dissociation can be written as Ha dissociate to give you what? Alkanoic ion and hydrogen ion. So the weaker the acid, the less it dissociates. So the more the equilibrium lies to the left. So the equilibrium is more to the left than to the right because it has to do with partial dissociation. So the dissociation can be written as what? Ha to give you A minus R plus what? H plus. So we can easily what? Get the acid dissociation constant for any monobasic organic acid. So looking at Ka and pKa, so the general equilibrium expression applying to a monobasic acid then becomes what? Ka is equal to the concentration of the hydrogen ion multiplied by the concentration of the alkanoic ion divided by the concentration of the monobasic weak acid. So the value of Ka indicates the extent of acid dissociation. So we use the Ka to determine whether it's a strong acid or a weak acid. It indicates the extent of acid dissociation. A high value for Ka indicates that the position of equilibrium lies to the right. That means the acid is almost completely what? Ionized. So the acid is strong. It's a stronger acid. The higher value for Ka indicates the position of equilibrium lies further to the left, right further to the right. So the acid is almost completely what? Ionized. So if we have a high Ka value, that means we're going to have a low pKa value, which is an indication that the acid is almost completely what? Ionized, which is an indication that it's stronger. A low value for Ka indicates the position of equilibrium lies to the left. That means the acid is only slightly ionized and exists mainly as Ha molecules are comparatively what? Few hydrogen ions and the alkanoic ion. That means a low value for Ka indicates what? A high value for pKa. Then the acid is only partially what? Ionized. That means a weaker what? It's a weaker acid. So with the value for Ka, we can determine what the strength of what? A weak acid using the Ka value. A high value for Ka indicates that the acid is almost completely what? Ionized. That means ionizes what? Completely, which is stronger. Then the low value for K indicates that the acid ionizes what? Partially, which is what? Weaker. So it's as simple as what? A, B, C. So still on Ka and pK, which is the acid dissociation constant. So we want to look at how we can calculate Ka and pK for a weak acid. Calculating the Ka and pKa for a weak acid. So we can calculate the value of Ka for a weak acid if we know the concentration of the acid and the pH of the solution. So we have to know the concentration of the acid and the pH of the solution. Now if you look at the equation we have here, the acid dissociates, which is a weak acid, dissociate to give you alkanoid ion and hydrogen ion. We assume that the concentration of hydrogen ion is equal to the concentration of the alkanoid ion. We can see that for each HM molecule that ionizes, one hydrogen ion and one alkanoid ion are produced. So this assumes that we ignore the hydrogen ion concentration arising from what? From the ionization of water. So it's an assumption that the hydrogen ion arising from the ionization of water is ignored. So that means the concentration of the hydrogen ion is equal to the concentration of what? The alkanoid ion. So if we substitute it in this equation, the equilibrium constant Ka, it will now be equal to what? Concentration of hydrogen ion squared divided by what? The concentration of what? The monobasic weak acid. So the acid dissociation constant is equal to the square of the hydrogen ion concentration divided by what? The concentration of what? The acid. So from there, we can calculate what? The hydrogen ion concentration to calculate the pH of the what? Weak acid. So calculating the Ka and pK for weak acid. So if you look at the conversion from Ka to pK is carried out. So the pKa, which is negative logarithm to base 10 of the acid dissociation constant, which is the Ka. So the Ka now will be equal to what? Antilog of what? pKa, or 10 raised to the power minus pKa. So to get the Ka will be equal to what? 10 raised to the power minus what? pKa, which is the antilog of the pKa. So you can convert Ka to pK. So if you are given the Ka, you can calculate the pKa, which is the negative logarithm to base 10 of what? The Ka. If you are given the what? pKa, you can calculate the Ka, which is what? 10 raised to the power what? Minus what? pKa. So it's as simple as A, B, C. So that is how you can calculate the Ka and the pKa for a weak acid. So once you know the Ka, you calculate the pKa. So having considered the lecture, so before it's a typical A-level chemistry question based on what we've done. So hydrogen cyanide, HCN, is a weak acid in aqueous solution. It's a weak acid in aqueous solution. It dissociates to give you hydrogen ion and the cyanide ion. The Ka is 6.02 times 10 raised to the power minus 10. This is the hydrogen cyanide. You are now asked to calculate the pH of 0.10 mole per dm cube hydrogen cyanide. Ka will be equal to what? Concentration of hydrogen ion multiplied by concentration of cyanide ion divided by what? Concentration of what? HCN. Now, since we assume that what? Since we assume that the concentration of hydrogen ion is equal to what? Concentration of what? The cyanide ion. So that means Ka now will be equal to what? Concentration of hydrogen ion squared divided by concentration of hydrogen cyanide. So the hydrogen ion now will be equal to what? Ka, square root of what? Ka, which is the acid dissociation constant, multiplied by what? The cyanide ion, multiplied by the concentration of the hydrogen cyanide, which is the acid. So hydrogen ion concentration will be equal to what? Square root of what? 6.2 times 10 raised to the power minus 10 multiplied by 0.10 square root. So you are going to get what? 7.9 times 7.9 times 10 raised to power minus 6, which is the hydrogen ion concentration. So we have to calculate the pH. So pH is equal to what? Negative logarithm to base 10. Negative logarithm to base 10 of the hydrogen ion concentration. It's equal to negative logarithm to base 10. Negative logarithm to base 10 of what? 7.9 times 10 raised to power minus 6 minus 6. So the pH now will be equal to what? 5.1. So which is approximately what? 5. So the pH is equal to what? 5.1. So it's as simple as what? ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. Thank you very much. So having considered Ka and pKa, so this is a typical what A-level questions based on what we've done. So please go through the lecture, go through the examples we've solved, and attempt the following questions. And please feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much.